Welcome everyone. Today I'm going to walk you through the cost optimizer for Snowflake. This Snowflake native application will help you to reduce your Snowflake credit leakages and reduce your Snowflake spendings, which you can utilize to bring more analytical services under the Snowflake platform. So let's start with installation. So first step is go to Snowflake Marketplace, search for NTT data. So here you can see all the applications published by my team at NTT Data here. So select Cost Optimizer for Snowflake. Here on this page, you can see information about Cost Optimizer for Snowflake, which includes how to use various sections into the application. It also specifies uses examples, including installation instructions and uninstall instruction. And it also publishes the security information, which describes what account level privileges this application requires, what object level privileges required, and what diagnostic information collected by the application. Let's click on Get to start installation of the application. We require to select warehouse that is used for installation. We also need to specify the name of application. You are free to use any name for this application. So by default, it is Cost Optimizer for Snowflake. And then click on Get. This application requires few permissions on your account specified into the security details. So to grant these permissions, you can copy this commands and just replace application name with a name that is given by. Now permissions are granted to the application. Now go to Apps tab and open the application. So on a first run, it starts initializing optimization services. Now optimization service initialization is done, so we can start using the application. During the initialization, Cost Optimizer for Snowflake analyzes Snowflake cost areas across the platform, including managed compute, warehouse cost, storage cost. It also analyzes serverless compute cost, including auto clustering, materialized view, and pipe. So we'll go through each of this one by one. So let's start with the overview tab. The overview section highlights summary of credits used at organization level as well as account level, which includes weekly cost in various Snowflake accounts within the organization and how it is different from previous week. Segregation of cost by service type at organization level and at account level. most frequent users and databases used, and the top costly queries in last 30 days. The warehouse utilization section takes deep dive into the warehouse utilization. It finds out warehouse idle time. The warehouse idle time is the time when warehouse is up and running, but not executing any query. And then it identifies the potential monthly saving in dollars if the warehouse idle time is reduced to 20%. This application is also looking into bytes billed to the local storage by warehouses and bytes billed to the remote storage by the warehouses. If a huge number of bytes are spilled to local storage and remote storage, it's a possible indicator that you are using very undersized warehouse. And you may require to scale up your warehouse size to improve the performance. It also looks for data cache utilization by the warehouse. If data cache utilization is very less, there is a possibility that the workloads are not grouped properly or the auto suspend time is very, very less. This application is also looking into queued load on the warehouses to find out possibilities of using multi-clustered warehouse. The auto clustering tab investigates the cluster tables and tables which possibly benefit from clustering, along with the recommendation on clustering key. This section inspects the query log to identify the best cluster key. This section also includes the capabilities like analysis of how frequently a table is reclustered and how frequently it is queried. The potential saving if auto clustering is removed from a less frequently queried but frequently updated tables. A materialized view tab investigates materialized views, their cost, frequency of use, and frequency of refresh. And then based on it, it builds recommendations about potential savings if less frequently used, but frequently refreshed materialized view are replaced by standard views and static tables. And it also identifies potential candidate views for the materialized view. The Snowpipe tab analyzes the Snowpipe uses to identify average file size and number of files ingested. And it builds a recommendation for the file size to be used and the potential saving if the recommendations are followed. The storage section investigates storage uses and identifies unused storage in the account. This section also recommends like candidate tables for drop and potential saving on storage if the tables are dropped. Optimization service refreshes all optimizations and recommendations in the background, and the setting tabs provides flexibility to change the frequency of execution of the optimization service. You may want to exclude some of the databases or schema from the optimization service. For example, you have a backup database and you don't want to execute optimization service on top of it. So to do that, go to the README file. Thank you very much. And if you have any additional question or query, please reach out to us at this email ID. Thank you very much.